Okay, I thought it might be time now to just summarise what we've so far come up with in parabolas and quadratics and sketching quadratics. You've done a 2-day self-directed task, and so you've picked up a lot of this stuff, but I'd like to get it sort of formalised a little bit, get it clear, and make sure we know what's going on before we move this section forward. So as you know, if you sketch a quadratic, parabola results. Now what's on the screen at the moment, we just explain what's going on the screen. This f of x equals, this is my function. Okay, for f of x you can just read y equals. So this is just y equals. Now you can see I've got, this is in turning point form. But the key component here is that there's a squared, which means it's a quadratic equation. And I've got values here of a, h, and k. The reason I've set it up like this is over here, look at my values of a, h, k. What I'm going to do is move these around, and we're going to see the changes to my curve as they happen, sort of thing. So at the moment, I've set my values of a as 1 and h and k are both 0. So what that means is basically I've got y equals a is 1, right? So 8, but h is 0, so this is just x squared in here, and k is 0. So it's just 1 times x squared or x squared. So on the screen at the moment, y equals x squared. What we're going to do firstly is what we did the other day, and just have a look at what happens with, but it'll just be a bit more obvious as we change a. So first I'm going to increase a, and just have a look at what happens, and perhaps, as you know, I'll just pause before I do each of these, and you can sort of anticipate what the result's going to be. But what we'd said here is that this graph, as a increases, the parabola becomes narrower. You get this becomes steeper or narrower is the sort of language we've used, and that's the case there. As we get, I'm going to take this back now to 1. And erase the traces. So we're back to x squared again now. As a decreases, can you predict what's going to happen? I'm now going to drop a below 1, but I'll hold it still positive. Okay, so here we go with that, and you can see that a starts fanning out and becomes wider. Sorry, the parabola becomes wider as a gets lower, and you can see what happens at 0.01 x squared is it's really flat, and at actually 0 x squared it just turns into a straight line. Okay, so that's the effect of a, and there's quite a nice pretty pattern on the screen there as well. So there we go. At the moment that's 0.01 x squared, and it's just done that. I'm going to change this a back to, let's get it back to x squared again. Back to that. Now let's just have a little look at the effect of changing a to -1. So what happens when we make it minus x squared? I'll let you predict that in your own mind what's going to happen before I hit enter, and there it goes. So it reflects in the x-axis, it becomes an inverted parabola, and if I control Z that, and you can see the result is just a flip. So negatives become inverted, sad face, however you want to think of that. Control Z, there it is. Okay, so that's a. Let's now change, we're going to hold a as 1, and let's change h around. So what happens when we move h? So this is the effect of introducing a value here into the bracket. Now it's x minus h. As h increases, so let's take it h, I'm going to take h in a positive direction up towards 1, 2. Try and predict now which way the graph's going to go, and what sort of changes you're going to see. Okay, away we go. Right, so you can see I've put a trace on it, so we're seeing all the graphs produced as they go, and if I stop this at h equals 1, and I remove the traces, you can see it's moved to the right by 1. So this is the equation. If you can think of this, it's x, a is just 1, so it's x minus 1 all squared, k is still 0. So this is just x minus 1 squared. And what the effect of that is to move it across to the right by 1. Okay, and if we go the other way, I put a minus 1 in there, it'll jump across, minus 1 in there, it'll jump across to the left hand side. So when h is minus 1 though, just think about that. I've got x, this is x minus h. So when h is minus 1, it's x minus minus 1. So this would look like x plus 1 squared. And so it's kind of counterintuitive in a way. When this is positive in here, x plus 1, it shifts to the left one. When it's minus 1, it shifts to the right one. And yeah, you can see what's going on as h goes further into the negatives, right, it just goes further left. Okay, Alright, so that's fine for h. We'll bring him back to, well, let's just bring him back to 0 so that we can concentrate, and I'll get rid of the traces, we can concentrate on just k now and what happens when k moves. Okay, I'm going to increase k, I'm going to make him positive, try and predict. Okay, did you get that right? The k on the end. So what we're doing is adding a value onto the function, so it just shifts it vertically up. I'm going to stop here at 2, and the result we'll see will just be to sit on the y-axis there at 2. So it's just gone vertically up 2. And then obviously if I make that a -2, you can predict the result. It's going to be at -2 down there. If I mix h and k, so what will happen here? I need to. Right, if I say increase h like so, then I get a turning point. That's why it's called turning point form. So I'll show you in a moment. I'll stop h at 1, and we'll see what the turning point is. I'll erase the traces. You can see where the parabola is. The turning point's down here at the coordinates 1, -2, which are exactly my values of h and k. So that's something that you need to just be aware of. And that's why this is called turning point form, because it's really easy to identify what the turning point is. Okay, I'm going to flip to the notes page now, make a couple of notes about what we've just talked about, and then we'll round up this screencast. Okay, so just take down this heading here, graphing quadratics and observing the various parabolas that result. Okay, we're getting, we've had a lot of information about this now, so let's just have a look at the basic y equals x squared. So just take down a couple of these graphs, and what happens then if that becomes a -x squared is that it inverts. Right, so if that would be y equals -x squared. So the note just to take there is that the negative inverts the parabola. Okay, so that's that one. Well, it's worth pointing out here before we go any further that every parabola has an axis of symmetry, and it goes right through the turning point. So in this case, it's right there. And we talked about this the other day. What that means is, this side will flip onto this side, and this side flips to this side. A parabola is a symmetrical object. So this here is my axis of symmetry of the parabola. Axis of symmetry. Now you've all looked at symmetrical properties before. With a rectangle, you've got an axis of symmetry here. Any sort of fold line is an axis of symmetry. You've got one there. That's probably it for a rectangle. For a square, you'll have diagonal ones as well. So you'll have 1, 2. You'll have that one there, 3, 4. For a circle, you've got actually an infinite number of axes of symmetry. You get the idea. In a parabola, it's the vertical line that goes through the turning point. I'll just make that note. Okay, you can see the note there, the vertical line that goes through the turning point, and the equation of it, the equation of the axis of symmetry, the equation, actually I'll choose a different color, that's bad, well, you've got loads of red in there. The equation, because you'll be asked for this, of the axis of symmetry, you can see what it is there, that's vertical line, that green line. The equation for it is x equals 0. So any vertical line has equation x equals whatever, depending on what that whatever is, wherever it is, wherever that vertical line is. Now, this vertical line goes through x equals 0. So the equation of the axis of symmetry is x equals 0. That's an important point there, and it's something that didn't come up in your self-directed task the other day. Okay. Let's move on to just looking at the variations for sort of left and right. So if you've got, if we just move, say, right by 2, so we're going through 2 there, then this will have equation y equals, it's gone right by 2, so it'll be x minus 2 squared. So that's right by 2. Now let's say it goes right by 2, this is a turning point focus now, and say it goes up by 3. So our turning point is now up here somewhere. So our parabola now turns there. Then this will have equation y equals x minus 2 squared in turning point form plus 3. So it's gone to the right 2, which means I've got a minus 2 in here. Remember, that's counterintuitive. And the plus 3 is intuitive. It goes up 3. So often think about this minus 2 being counterintuitive. And what that means is, the intuition is, if it says minus 2 here, that you go left 2, because minus means go left. It's counterintuitive inside the bracket. That means shift right 2. And then the plus 3 is normally, as you would expect, up 3. If there's a number in front here, the ax squared, then that just affects the width of the parabola. That's probably all there is to talk about at the moment, and we can get into chapter 7, 7a, 7b when we next meet in class. Okay, see you then.